Hi, I'm Ben-Yaakov. This is a riddle about inductor discharge. I'm showing here a situation which looks like a paradox, and the riddle is to explain what is really going on. So here is the setup. We have here two different ways of driving an inductor. This could be a solenoid, a relay, or contactor, which has a 100 millihenry inductance and then some DC resistance. This is the conventional way. We have a transistor, a MOSFET, and then we need a diode to capture the current when the transistor is off. Otherwise, we're going to have here very high voltages. I've also added a resistor such that the voltage developed here, the negative voltage, will be a little bit higher than just the drop on a diode. By this, the current will drop faster than just with the diode. On the left side, we have a different topology for the same purpose. We have here in the inductor, then there is a resistance, the same thing here, the same source, we are driving it, and then it turns on, and the current, of course, will build up as here. And here, I also have a diode, but notice that this is a very large resistance. As I'll show later on, this really doesn't matter. If I would have put a resistor of large resistance in this case, then all this current coming through this resistor will build up a very high voltage that may damage the transistor. As we'll see, this is not happening here. So let's have a look what is really going on. Here I'm showing the current of the inductors. This is the conventional topology. This is the current of the inductor, and this is this one which goes down as would be expected exponentially when the diode is capturing and there is some resistance, both of the 2 ohm and the internal resistance, which is small. And then we have the current in this case. It's also building up the same way. I've adjusted so it'll be the same because it's the same inductance, same resistance. But you see that the decrease is different. It's actually linear here. Okay, but that's not all the differences. If we look at the current of the diode or the resistor, in the conventional case, we see that the current goes to the current of the inductor. In this case, about 500 milliamp. Same thing here because it's the same current here. And then it drops exponentially, exactly like the inductor because it's the same current, okay? But look what happens here. If I look at the current here in this diode or resistor, it's only 2 milliamp. So with the 1K resistor, the voltage drop is only 2 volts. That's it. And it's a different behavior altogether. So this behavior here is really very much different from what you will see here, although it sort of looks the same. So here are the question of this riddle. In the sourcing topology that I've shown, the questions are, why is the resistor current low? Where is the inductor energy dissipating? And what are the options for changing the current magnitude? I'll be happy to get comments and answers, but I may not be able to respond to all of them. In a forthcoming video, I'll give my explanation to this sort of strange phenomena, but obviously it has an explanation. So thank you for your attention.